Welcome to the course of differential equation. In this session, we will discuss about the method of undetermined coefficients, part 4. We already discussed, before it we discussed 3 sessions related to method of undetermined coefficients. We know that for a differential equation, second order differential equation, a y double dash plus b y dash plus c y is equal to some g of x is a second order linear non-homogeneous differential equation. It is a second order linear non-homogeneous differential equation. So, to solve this, we used some methods and we discussed it is that based on the r of x instead of g of x. Before I think we used it is r of x, or based on the g of x we can define. I would like to change this as the instead of this, which I would like to change this as some r of x. This is equal to r of x. Say, dear students, in this we can say that this r of x is the non-homogeneous part. Based on the value of r of x, based on the function r of x, we can define a particular solution yp for this differential equation. We already know it is that the general solution of this differential equation is one is y is equal to some yh plus yp, where yh is the particular general solution of the it is a complementary solution, that is a complementary solution of the homogeneous part, that is the solution of a y double dash plus b y dash plus c y is equal to 0. Based on r of x, we can have a particular solution for this context, and this particular solution is yp. Okay. There we have 9 choices for yp, and we already discussed, I think, the 6 choices we discussed. See, dear students, we have here based on the value of r of x, we already discussed about the r of x. Maybe if r of x is equal to some exponential function, so we can say that this is equal to some k e raised to px. Maybe if it is some k e raised to px, then definitely we will have the choice for the particular solution, yp, choice of yp as we discussed, it is choice of yp as this is equal to some c e raised to px, some c e raised to px. Fine. This is the first choice for if the r of x, if the non-homogeneous function is exponential function, then we can we will apply yp like this. We will consider yp as c e raised to px, and after applying the yp dash, yp double dash into differential equation, we can find the value of c. Then we will get a particular solution for this non-homogeneous equation yp. Now, maybe sometimes that is the nth degree polynomial, that is the Pn of x is the nth degree polynomial. Then we can have the yp as kn x raised to n plus kn x raised to n plus kn minus 1 x raised to n minus 1 kn minus 1 x raised to n minus 1, okay. Kn minus 1 x raised to kn minus 1 x raised to n minus 1 plus etc. plus k1x plus k0, k1x plus k0 is there. So, after applying, finding this is yp, also we will find yp dash and yp double dash, and then we will apply into our original differential equation. After applying this into the equation 1, we are able to find out this one value of k1, k2, etc., kn and k0. So, we will have a particular solution yp is there. Maybe sometimes they have a choice for the this is equal to sin px, or maybe r of x is the cos px is there, maybe the sine function or the cosine function is there. If in either cases we can say that this one as the yp, the choice for yp as a cos px plus b sin px is there, b sin px is there. Maybe sometimes somebody used it here instead of px, maybe qx is there, kx is there, anything can come, no problem. Here p, q and k are we treat like a constants. So, dear students, this is the a cos px plus b sin px, and we will find yp dash and yp double dash, and finally, we will get the value of a and b. So, we will get a particular solution for that non-homogeneous equation. So, these are the three major choices. These four functions may be three major choices for the r of x, and we can find the corresponding yp like this, and we can find their coefficients. So, we will get the particular solution, actual particular solution for the non-homogeneous equation. This is what is called the method of variation of method of undetermined coefficients. So, see my dear students, maybe there these three function types are here, their combination will may exist as r of x. Maybe suppose they have a choice to exist r of x as, there may exist r of x as some exponential function into trigonometric functions, that is k e raised to px cos qx is there, or k e raised to px sin qx. Okay. This is the combination of the exponential function and trigonometric function. We already found it is that this is the choice for the exponential function, this is the choice for the trigonometric functions. Their combination will be the choice of yp, and therefore, we can have this is equal to some e raised to px into a cos qx plus b sin qx is the choice for the yp, is the choice for the yp. Okay, fine. We have choice for yp like this. Okay, no problem. We can apply yp, and then we can find the yp dash, yp double dash. We will able to find out the value of a and b. So, we will get a particular solution for that. And similarly, maybe the choice for the exponential function and polynomial functions are there. Some Pn of x into e raised to pt is there. Sorry, Pn of x into e raised to px is there. Okay. Maybe sometimes in some equations we will use variable, independent variable as t, no problem. Okay. But here Pn of x into e raised to px is there. So, we will have this is the e raised to px into, we have the choice for Pn of x is here, that is the nth degree polynomial. So, that nth degree polynomial will be there e raised to px into kn x raised to n plus kn minus 1 x raised to n minus 1 plus etcetera plus k1x plus k0 is there. Fine. And finally, maybe here we discussed exponential combination of the exponential function and trigonometric function, and we discussed a combination of the exponential function and polynomial function. Maybe there may have a chance to exist r of x as a product of three choices, the product of exponential function, polynomial function and a trigonometric function. Okay. On that case, we how it will be there? See, dear students, maybe r of x as, maybe r of x as some e raised to px, some e raised to px k e raised to px into Pn of x, some e raised to px into Pn of x, okay, k e raised to px into Pn of x, e raised to px into Pn of x into the trigonometric function is there, some cos qx is there, or maybe that may be the some k e raised to px, some k e raised to px, k e raised to px into the polynomial function into some sin qx may be there. Any of these choices, no problem. In both the cases, we can write this as the product of see we can have the nth degree polynomial is there. On that case, we can have this is equal to some kn x raised to n plus etc. plus k1x plus k naught into the e raised to px is there, some cos qx is there, e raised to px into cos qx is there, e raised to px into cos qx is there, plus we will have the choice for the sine function is there. So, we can have another polynomial, some I can say this is equal to ln x raised to n. Ln is the coefficient of the nth degree x raised to n, coefficient of x raised to n, and ln minus 1 x raised to n minus 1 plus L1 x plus L naught into e raised to px into e raised to px into sin qx is here. Okay. This is the final choice, see dear students, that is the final choice of the that case. Okay, fine. Fine. So, see there is a combination of all the things that we discussed. So, so we will have the 9 different functions are there, and we have the 7 different choices may exist here. So, dear students, based on that we have to find this is the choice of yp. As because this is the choice of yp, we have to find the yp dash and yp double dash, and then we will apply the original differential equation, the non-homogeneous equation, and after applying that we are able to find out the value of the constants k naught, k1 etc., kn, L naught, L1 etc., Ln, and finally we will get the solution. That is the particular solution. Okay, dear students, and in this session one more interested is that we will discuss about the rule 1b. The rule 1b discuss it is that, see dear students, we discussed here it is that here we may have the equation as second order non-homogeneous linear differential equation as ay double dash plus by dash plus cy is equal to some r of x. This is our first equation. See dear students, this r of x is the non-homogeneous part. We already discussed it is that r of x have 7 different choices. We discussed it is that it may have the 7 different choices maybe. See, suppose maybe from the any of these choices maybe this r of x as sum of the other choices may be there. So, if r of x is sum of 2 functions from sum of 2 functions from column 1, sum of 2 functions from column 1, sum of 2 functions from column 1, that is what about the column 1. See, can have this is the column 1, that is the choice of r of x is there, k raised to px, pn of x, sin px is there, cos px is there, and we will have the combination of exponential and trigonometric functions are there, maybe the combination of the polynomial function and exponential function are there, maybe the combination of exponential and polynomial and trigonometric function is there. If any choices is there, no problem, but among that choices their sum is the this r of x. So, we will have here we will have the second column, the correspondingly we will have second column for all these choices. So, we will get the yp as yp has choice as sum of corresponding functions from column 2, sum of corresponding functions from column 2, sum of corresponding functions from column 2. See, that is the sum of corresponding functions from column 2. This is the choice of yp. We will take the sum of the choice of the yp's. Okay, fine. We will have a principle of superposition is there, that we discussed in the case of that this one. Say here the principle of superposition, that principle of superposition says what we discussed here in rule 1b. See, dear students, the principle of superposition, that we can define as, that we will discuss as the principle of superposition, we will discuss it is that maybe if y1 of t is a particular solution of, maybe if y1 of t is a y1 of t, instead of t I would like to consider here as x, y1 of t, y1 of x is a particular solution of, y double dash plus a y dash plus b y, y double dash plus a y dash plus b y is equal to some g1 of x or r1 of x. Okay. And similarly, y2 of x, y2 of x is a particular solution of, y double dash plus a y dash plus b y is equal to some g2 of x, Here see, in both cases the left side is same, in both cases see the left side is same. Okay. In both cases the left side is same, only the difference it is that g1 and g2 are, g1 of x and g2 of x are different. So, we can say that we will have this is y1 of x and y2 of x are the solutions. So, we can say that then see, then we can say that then y is equal to y1 of x plus y2 of x is a particular solution of, a y double dash plus b y dash plus c y is equal to g1 of x plus g2 of x, So, dear students, I would like to say, to find particular solution of the equation, second order linear non homogeneous equation a y double dash plus b y dash plus c y is equal to some g1 of x plus g2 of x, it is enough to find the particular solution of y double dash plus a y dash plus b y is equal to g1 of x, y double dash plus a y dash plus b y is equal to g2 of x, and after getting particular solution, this is yp1. So, y1 for this and y2 for this, we will have the particular solution of this differential equation is their sum, y1 plus y2 is the actual yp, y1 plus y2 is the actual yp. So, that the principle of superposition says. See, my dear students, we can move to an example, can see the example, solve the non-homogeneous differential equation, solve the non-homogeneous differential equation, y double dash minus 3y dash plus 2y, y double dash minus 3y dash plus 2y is equal to 40 plus e raised to 3t, 40 plus e raised to 3t is there. See, dear students, this is the differential equation. See, here we have the differential equation, this is second order equation, linear with constant coefficients and non-homogeneous. See the non-homogeneous part, here the non-homogeneous part, the 40 stands for the P1 of t. So, I would like to change t as x, that since we discussed all the questions in terms of x as independent variable, 4x plus e raised to 3x is there. Okay. So, see this is I would like to say this p1 of t, p1 of x, this is the p1 of x plus some e raised to this one 3x is the e raised to some px is there, that is p is 3. See, that is the sum of combination of the r of x from the column 1. So, for this it is enough to find the particular solution for we can say that we will have the particular to find yp of 1, to find yp of 1, to find yp of 1, it is enough to find, 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 it is enough to find yp1, yp1 as a particular solution of y double dash minus 3y dash plus 2y is equal to some 4x. Okay. And the second in second case we can find the yp2, yp2 of the same this one homogeneous part y double dash minus 3y dash plus 2y is equal to some e raised to 3x is there, some e raised to 3x is there. Okay, fine, and we will have this is the yp as this yp is equal to this yp1 plus yp2. Okay, that yp is equal to that yp1 plus yp2. Maybe in some sometimes we can say that instead of this one or otherwise we can have the yp instead of this is the first degree polynomial, that is the k1 of x plus k2 or k0. Okay, constant term is there. So, see this is enough. In case of that we can have this is equal to y double dash minus 3y dash plus 2y is there, y double dash minus 3y dash plus 2y is there, minus 3y dash plus 2y is there, and finally here we will have this is 4x plus e raised to 3t, sorry e raised to 3x is there, 4x plus e raised to 3x is there. This is actually the r of x. So, I already told you maybe we are able to find, the solution like this, and we can apply these two things, no problem, we will get it. Or otherwise we can have the 4x as k1x plus k0, this is equal to some e raised to 3x is there. So, yp I would like to say the yp as their sum. So, we will have yp as this is equal to yp is equal to sum, this is equal to as because 4x is a polynomial first degree polynomial, that is equal to k1 of x plus k0 is there and plus e raised to 3x is there, that is the c e raised to 3x. Okay, fine. So, I would like to find the yp dash, this is the yp dash, here we will have the yp dash. See, yp dash is equal to some k1 of x is there. We will have this is the k derivative of k1 of x is actually k1, derivative of k0 is equal to 0 and plus c e raised to 3x is there. That c e raised to 3x is 3c e raised to 3x. Fine. And yp double dash, while evaluating yp double dash, here we have k1 is the constant. So, that we will have here this is equal to 0, only 3 c e raised to 3x, derivative of e raised to 3x is 3 e raised to 3x. Therefore, 3 into 3 9 c e raised to 3x is there. Okay, we can apply to this is our equation 1, we can apply into 1. Okay, while applying to 1, apply in 1. So, yp double dash minus 3yp dash plus 2yp is equal to 4x plus e raised to 3x is there, 4x plus e raised to 3x is there. So, dear students, we will have this is equal to yp double dash and this is equal to yp double dash. The value of yp double dash is 9c e raised to 3x. 9c e raised to 3x. Okay. Then minus 3 yp dash 3k1 plus into 3 into 3 c e raised to 3 into 3 9c e raised to 3x is there. So, we will have minus 3k1 yp dash k1 is there. So, minus 3 into 3 minus 9c e raised to 3x is there, minus 9c e raised to 3x is there. Okay, fine. And finally, we will have this yp as k1 of x plus k0 plus c e raised to 3x is there. So, we will have this is equal to 2 into k1 of x. Therefore, 2 k1 of x plus k0, that is 2 k0, and finally, we will have 2 c e raised to 3x. Okay, is equal to 4x plus e raised to 3x is there. See, dear students, here we will have minus 9c e raised to 3x is there, and also here we will have plus 9c e raised to 3x is there, that we can cancel, and finally, we will have the constant term is there. Here this is the coefficients of constant terms are minus 3k1 and plus 2k0 plus 2k0. Okay. While comparing coefficients from the both sides, here there is no constant term is there, the constant term is 0. Therefore, this is equal to 0. Okay. Compare the coefficients of x. Okay. We will have this is equal to 2k1 of x is equal to some 4x is there. Okay. Only the term containing x is the 2k1 of x is here only in LHS, and 4x is there in RHS. So, we will have this is the 2k1 of x, that is the 2k1 is there, coefficient of x is equal to is equal to 4. This implies k1 is equal to, this implies k1 is equal to 4 by 2, that is equal to 2, k1 is equal to 2, k1 is equal to 2, we found. Put k1 is equal to 2 is here, therefore, while putting k1 is equal to 2 to here, we will have 3k1 is equal to minus 3k1, that is equal to minus 6 plus 2k0 is equal to 0. Minus 6 plus 2k0, minus 6 plus 2k0 is equal to 0. Therefore, we have 2k0 is equal to minus 6 is there, 2k0 is equal to plus 6, while coming negative to RHS, that will be positive. So, k0 is equal to 6 by 2, that is 3. Now, we found the value of k0 and we found the value of k1, and finally, we have a chance to compare the coefficients of e raised to 3x. Here we have 2c. So, we already used this term, we already used, and this we used, and this also the constant is we used, and all this 4x is used. It remains only this part, some this one 2c e raised to 3x is equal to some e raised to 3x. So, that is equal to 2c is equal to 1. So, finally, we will have finally, we will have 2c. Therefore, we will have 2c is equal to 1. Therefore, 2c is equal to 1. That is c is equal to 1 by 2. So, we found the value of yp. Now, c is there, k0 is there, and k0 is equal to 3, c is equal to 1 by 2, and we have k1 is equal to 2. So, therefore, we will have the particular solution as k1 of x, k1 is equal to 2x plus 3 plus 1 by 2 e raised to 3x. Therefore, yp is equal to, therefore, yp is equal to, therefore, we can say that yp is equal to k1 of x, that is equal to 2x plus 3 plus 1 by 2 e raised to 3x. 1 by 2 e raised to 3x, 1 by 2 e raised to 3x. This is the particular solution for the non-homogeneous differential equation. Okay. And dear students, I did not discuss about the solution of the homogeneous part, and I left that is an exercise to you, and on that exercise you can find the equation for this one. You can find you can find that equations are, that is the homogeneous part is there. So, you can find the solution of the homogeneous part, that is to find YH, that is to find YH. You can find the YH, the solution of the homogeneous part, as y double dash minus 3y dash plus 2y is equal to 0. You can have the auxiliary equation as lambda square minus 3 lambda plus 2 is equal to 0. Okay. While evaluating this, you can have, this is the product of that is the minus 1 into, we will have the values minus 1 into minus 2 is equal to plus 2 is there, minus 1 plus minus 2 is equal to minus 3 is there. So, we can have lambda is equal to we can have this is equal to lambda minus 1 into lambda minus 2 is equal to 0. Maybe sometimes we used, instead of lambda, m is used, no problem. Okay. So, we found the lambda is equal to 1 and lambda is equal to 2 is there. So, we will have the solution of the homogeneous part as y is equal to C1 e raised to lambda 1 x, that is the C1 e raised to x plus C2 e raised to lambda 2 x e raised to 2 x is there. See, dear students, we are happy, that is the YH. Now, the general solution, therefore, the general solution of given non-homogeneous equation as y is equal to YH plus YP is there. Therefore, y is equal to YH is the C1 e raised to x plus C2 e raised to 2x plus 2x plus 3 plus e raised to 1 by 2 plus 1 by 2 e raised to 3x is there. So, this is the general solution of the given non-homogeneous equation by using the concept of the method of the undetermined coefficients. So, we can have we can find many interesting questions by we can solve by using the method of undetermined coefficients. And okay, thank you for watching this video. You may try to solve more problems on this method of the undetermined coefficients. Thank you for watching. Thank you very much.